In this example, the figure shows a U tube of base length L in which a liquid of density rho is filled such that it completely fills the base length only, which we can see here. If the tube is now rotated at angular speed omega with respect to an axis of rotation passing through one arm of the U tube, we require to find the level rise of liquid in other arm of tube. Here we can directly see when the tube rotates, the liquid which is filled in the base of the U tube will experience a centrifugal acceleration, due to which the pressure on right hand side will increase and it will start raising up in the liquid, and from this side it will be slightly displaced. The situation which we can see here in the figure, in this figure we can clearly see that due to the centrifugal acceleration omega square r, which we also studied in one of the early section, due to this centrifugal acceleration, the pressure increases and the liquid level will be raised, say up to a height y. And here we are required to find the value of y. So, in this situation, if you carefully analyze, say there is a point x over here. So, if we find out pressure in solution, if we find out pressure at x, then pressure at point x can be given as Px is equals to P atmospheric plus y rho g, as this end of the tube is open to atmosphere, so here P atmospheric will be acting. So at this point it will be P atmospheric plus y rho g. And pressure at x can also be obtained from this side, as here also the tube is open and pressure is P atmospheric acting. So for this what we do is, at a distance x from the axis of rotation we consider an element of a dx, and say we consider here pressure is P, here it is P plus dP. Then we can say on the base length of U tube we have, here we can write dP is equals to, this is dx rho omega square x. So we can simply write the pressure difference between x and P atmospheric, which is Px minus P atmospheric, can be written as integration of dP, which is integration of rho omega square x dx, and it is integrated from y to L, as the liquid is raised up to a height y. So here also it will be displaced by a distance y, so we'll integrate it from y to L. So this will give us the value of Px, which is equals to P atmospheric plus, if we just simplify this expression, this will give us rho omega square by 2 multiplied by L square minus y square. And the same pressure at point x we already obtained from the vertical side of the tube. If we equate the two, it is P atmospheric plus y rho g. In this expression, this P atmospheric gets cancelled out, and on simplifying we can see there's a quadratic equation in y. And if we just simplify the expression, let's continue it on the next slide. So this is the equation which can be further simplified as y square plus 2g by omega square y minus L square is equal to 0, as a rho gets cancelled out, and on simplifying we can transform it into a familiar quadratic form, and on solving this equation we get the value of y to be minus 2g by omega square plus root of 4g square by omega to power 4 plus 4l square divided by 2. So this is the height y up to which the liquid level will be raised in the right hand U tube of the system, and this can be taken as the answer of our problem.